In this video, we're going to look at aldehyde and ketone reactivity. So discuss a little bit about how to form them. If I've got a primary alcohol and I add an oxidant, I can create an aldehyde. If I have a non-primary alcohol, I can add oxidant and I can get a ketone. Be wary, if you have a tertiary alcohol, well, that doesn't make either of these. There's no hydrogen to remove the way there are in the primary and the secondary. Nothing happens if you try to oxidize your tertiary. So aldehydes and ketones can only be formed from these primary or secondary alcohols. What can we do with the aldehydes and ketones? First and foremost, your aldehyde, we'll use our propanal. If I add a reducing agent, these can become alcohols. Just the reverse of its synthesis. So remember, every reaction generally can be reversed. This is how we reverse our aldehyde formation. We can turn an aldehyde back into an alcohol. So aldehyde to alcohol. What is a reducing agent? There are a lot of reducing agents for various things, but for our purposes, these are generally H2 with a palladium catalyst. And so I need more hydrogens. So there's technically 2 hydrogens. There was the one not shown. I need to add 2 hydrogens, 1 to each of those original atoms that had the double bond. And so H2 with palladium is a great way to do this. And so you can reduce an aldehyde back into an alcohol. Same with a ketone. If I have a ketone and I was to add H2 and palladium, I would get a secondary alcohol. One of those hydrogens would go on the carbon that had the double bond, and one of them would go on the oxygen that had the double bond. And so both of these can be undone and returned to alcohols using a reducing method, generally hydrogen with palladium. Aldehydes can also be converted into carboxylic acids with the addition of more oxidant. This readily happens. Aldehydes are very reactive molecules. Even dioxygen in the air is oxidizing enough to turn an aldehyde into a carboxylic acid fairly easily. If you leave a bottle of aldehyde open to the air, it generally won't be aldehyde come the next day. In terms of reactivity for this course, these are the main reactions that we will see. There are actually several other ones. Both of these double bond oxygens react with amines to form imines, imines. However, they are not a focus or a topic covered in this course. So there are more reactions of aldehydes and ketones than this, but this is the extent for our class.